that we have a presentation here, an interactive discussion. Yes?
I'm writing notes about That's true story.
Everyone says I'm doing the minutes, and in the meantime you are working on Facebook or Twitter or whatever. Okay, then give a remark when it does something else. Okay. So, who of you knows ENISA? Ah, that's great. Why do you know ENISA? Yes, but that's okay. We are a European agency dealing with cybersecurity, supporting the Commission, the Member States, looking into technologies, writing papers, and are involved in legislative implementation. Currently in the electronic identity management, the so-called EIDAS directive. I want to talk today about smart homes and smart cities. Does everyone know what this is? Smart homes? Yes? Well, then I can go, I don't have to talk anymore. I hope it's not a boring presentation. The challenge is a bit that if you look into our task as a European agency, it's also about prevention and advice for policymakers. So the biggest challenge is that if you are in the technology business, then politicians make decisions, and the question is on what basis do they make decisions, what advice do they get? And the biggest problem is to translate what you are doing in your daily business of IT research, for example, into policy language that those people understand it. Well, there's a challenge with the enter key, because it doesn't move to the next slide. The keyboard is detached. Nothing. No key. I can tell you a funny story. I have a Surface from Microsoft. It's a great device. Does anyone know the Surface from Microsoft, this tablet? And you know the Apple iPad. The big difference is that Apple designed it from scratch with the user behavior, which is try to implement normal behavior. What Apple did is, they made a touch screen simulating the mouse. Because the challenge for Microsoft is that they have all this legacy application from the past, that it has to be compatible. If you ever try to do on a Surface, to edit an Excel sheet, it's a nightmare. Because the finger you are lost, or my fingers are too thick. If you take this pen, it becomes tricky because you have buttons on the pen. So it's something where it shows what is the difference is if you want to go into this new technology market. Now I'm like a moderator in television to bridge this after the presentation. Okay, then let's start with the discussion. You know the Internet of Things. So, what do you understand by Internet of Things? Yes? Okay, so, how long do we have this technology? Oops.
It's evolving, it's not like something that just came up. Everything like has been connected to, we have spread the internet and everything connected to the internet, and we have some smart things like we are making some sensing inside.
Yeah, that's correct. If you look into the evolution of the internet, okay, I don't look at those people who are older than 35 years, yeah? Because they're still sitting in front of the PC and stuff. I think everyone else is grown up with a mobile phone or smartphone. Can you imagine that 20 years ago you didn't have a phone, a mobile phone? And if you look back, I remember when I was a CEO in the insurance business before, it was end of the 19th. I had a discussion with the board about introducing emails. In 1989-99, they asked what is the use of having an email address and a website address. You cannot imagine this today. So if you look into the usage of the internet, it's only about 10 years really that it's a business model. And if you look into the technology, I was working in Germany for an agency in 2004. We made a study on Internet of Things, ubiquitous computing. Everything what I present today was in research studies 10 years ago, but it was not implemented. The problem is you look into RFID technologies, this RFID tags. There were great ideas in 2003 and 2005 to put RFID tags into supermarkets on milk bottles. But the problem is, if an RFID tag costs a couple of euros, you don't put it on a bottle of milk, which costs €1. What you have since 3, 4, 5 years, does anyone know Gary Weber clothes? They have it now in their production. This means in their production they put RFID tags into clothes, because if you buy something like for women, might be more expensive for 800 euros, then you can put in €1 RFID tag in. Then it's a business case. So what you see today, this is really amazing, how many companies produces what you said, sensors, boards, all these little chips, and they only cost a couple of euros or cents. If you buy it in China, you can smoke sensors for a couple of cents, and the biggest challenge is that you get them shipped to Europe, which is the biggest cost, but it's still only a few euros. So this means we are today in a situation that the technology is cheap enough that is deployed on a greater basis. So if you look into this, then we call it, from a governmental perspective, critical infrastructures. And for critical infrastructures, and this is something what I want also to give you as a message is, if you look from a governmental perspective, what is the main role of a government?
Provide services.
Trying to get your taxes. So, but the main purpose of a government, since ages, centuries, decades, is safety of citizens in the territory. If you look back, it's kings protecting the citizens, it's nation states protecting the citizens. When you talk about it that we want to have a safe life, therefore we have police forces, we have courts, we have rules how to behave. And the basic problem is now that from a governmental perspective, in which areas do you act and regulate? And if you look at this, then you can see that the government, European Commission or other states do it in certain sectors. We all have passports, we have RFID chips in passports. This means security in passports, governmental products. Healthcare is governmental interest. Networking is governmental interest. Water supply, banking system. But the media sector is not so much in the governmental interest. It's really privatized. If you look, I think it was now 2 years ago when the Sony PlayStation store was hacked. Nobody talks about regulation for this kind of business. If you look into the car business, it's private business since 100 years. But now government thinks about it because IT, connected driving, assisted driving comes into it. So the government and the agency look into the sector. So this is a basic principle when a state thinks about soft regulation with recommendations or with, let's say, legislation which implements and certain things. So this means if we talk about critical infrastructure, it is those critical infrastructure which state perspective which is important for running a state. As I said, It's electricity, it's networking, it's interesting banking system, as you see in Greece now. So there are a couple of sectors where the state looks into it. And this is something which gives you a picture. This means also you have regulation for aircraft, trains and cars. Normally you cannot put a car on the street without a type approval. And there's strong regulation if, let's say, a type of an aircraft can fly or is grounded if something happens. The problem we have is that we don't have such regulation on the internet, on the cyberspace. The first question to you as a young generation, do you want regulation like we have it in these other sectors in the cyber world? Do you think we need it? Maybe it's too big the audience to discuss it in this way. Okay, there are different opinions, but you see, this picture shows then in which areas we talk about real infrastructure and now about smart grids and smart cities. It's, from this perspective, seen as a real infrastructure. If you look into it, here is a couple of examples from the European member states. If you look at Austria, Belgium, Czech Republic down to Poland, it's energy, water, food, health, and so on. And you see that there is an agreement everywhere that energy is a critical infrastructure, but for example, in a couple of other states, it's not, let's say, the same view on critical infrastructure in every member state, but at least there is, in a lot of cases, a lot of overlap. So, this means, when we look at this, we call now this cyber physical systems. It's nothing new in this sense, it's only, let's say, a new term to define it. It's all these things, what is about sensors. So, a good example, which is currently an interesting, partly regulated in Europe, are smart meters. These are electricity meters in households, and the idea is that they are now connected to the internet, and that you have then, let's say, detailed documentation of the consumption in your household, where you use electricity, and that nobody has to come into the house to look at the meter, what you consumed, and that there's an interface to the electricity company. So, the interesting background is, let's ask you, what is the background that the industry wants to have electricity meters in a digital way? What do you think is the background?
Connectivity?
Yeah, why should you connect it? Why should I connect my electricity meter to the electricity company? What is the advantage?
You can stabilize the network more, know the consumption in each area, in each hour.
Exactly.
And the billing thing.
The background is that if you have solar panels on the roofs, a lot of people now put electricity into the grid, in the energy network. So this means it's not anymore a central control which controls the network. It's something where different suppliers, private person companies put it in, and now you need something where you regulate this electricity network. And this means to regulate something, you need sensors, and one of the sensors, the electricity meter, becomes a sensor. So, if we look in this, then the question is, what happens with all these connections? So, these slides are only background information, so I will give you the idea behind, and slides are for me, like, you know, the moderators in television, the small cards, but I don't use the line of this presentation. The challenge now with electricity meters is that these are done by engineers educated in the analog world. They don't have any clue about IT security. And if they are, let's say, over 40 years old, then they have to be trained on the job that they now put IT into it. Yeah? So the question is, how do you get IT knowledge into this? And the danger in all these things is that you put new technologies in place. It's great for convenience or for business models, but the people forget about IT security. So the question is, how do you get security into these systems? So, there's something which is an easy method in industry. It's risk analysis. So, But the challenge is, how do you do a risk assessment in a small company with 50 people, where you build for 30 years analog meter, but you don't know it. So the question is, where do you get the knowledge? So the knowledge is hopefully in this room with the young people, that if you go into this company, you teach them about IT security. So the question is then, you also look from the threat landscape. I come to this in a couple of minutes. Then the question is, where do you come with regulation? So, some of you might know that in Germany, 80 million people, there was a couple of years a decision to go from nuclear power plant to a non-nuclear power plant energy infrastructure. Let's put it like this. So to turn off all nuclear power plants over a couple of years or decades. So it's a political decision, it's different backgrounds, but when you now come to this energy, new energy discussion then the question is, in which areas do we put regulation in place? So what the German government did is, they made a regulation for big consumers, like those companies who produce steels or cars, who are big energy consumptions companies, or big, let's say, owners of big flats of houses, where you have real estate companies who own 500 or 600 flats with which they rent. So in this business, they put a regulation, not for the private consumer, for smart meters. So what we do from ENISA, you can download this threat landscape report. It's an analysis of threats. So just to give an example, this is typical things you see. It's in our service attacks, botnets, web attacks, so I don't want to go into detail. What is interesting is that if you look over the years, what is the tendency? Botnets, well, they're still out there, but there are a lot of mitigation strategies to reduce botnets. New threats coming up, like, let's say if you have websites with advertisement, the criminals now hack the advertisement part. And by this, if you click on the advertising part, you come to a little malicious websites. So this is something where we analyze this. So the point is, we don't have smart cities or smart grids as an attack vector here in this report. So you can say, okay, the world is good, but the problem is that, and you can see it over the years, crime goes anytime there where you can make money. And my best example is bank robbery. In the past, you need a pistol, and it's difficult to get a pistol. Do you know where to get a pistol here in Iraq? So you have to be a criminal to get a pistol. If you want to go on the internet, it's called phishing. But every one of us can surf on the internet, and if you are a bit, let's say, intelligent, you can find people who offer malicious software on the internet. You can run botnets. So there is an economy on the internet. It's much more easier to get this, let's say, malicious weapons, and as a criminal, how normally you get the criminal. But it's much more easier to get phishing tools than to get a pistol. But the principle behind this, you get money by this. So the question is, when is there, and it's a little bit strange to say this, when is there a business model for criminals to attack smart infrastructures? Today it's not a business case because it's not so much there, but there will be some point in time where it will be then something. So, this is just an example how this then works. When we look into this, we talk about security objectives, we talk about security measures. Maybe this slide is not, let's say, self-explanatory. If you dig in, there are reports for this. So if you are interested in this, let's say, analysis of potential threats, it's then described there. So now let's look from another perspective. If you have a government, you want to have information. Well, the best example is, since Snowden, that's just an agency to collect information. But not our topic today. Our topic is that in other areas, government makes statistics for a lot of things. So, in the telecommunication sector, we have a regulation which collects incidents in the telco sector. So typically, if your mobile phone doesn't reach a base station because the base station is not working, then the question is, what is the reason? Power outage, software, hardware failure. So this means the national ISPs have to report it to the national regulator, and we get it on a European level from ENISA. And this is something what is described here. You have here the service providers, the national authorities. It comes to ENISA, the European Commission will be also informed, and then we get a yearly report, which then describes what kinds of incidents are there. So, what I put here is this as an example where government, let's say with new technologies, okay, base station are not new technologies, but now if everyone has a smartphone, the smartphone, mobile base station infrastructure becomes a critical infrastructure. And therefore the interest of the state, and therefore the state looks into breach notification. We have currently the privacy regulation under negotiation in the parliament, the data protection regulation. There will be a breach notification in it. So this means with these new technologies, there will be more and more reporting obligations, and within a question of time, if you come back to the energy grids, when these big companies also have to report their incidents, because this is something what is then for statistics interest. So this slide, distributed, just gives you some references where we published what I just told you in papers, if somebody wants to read it. So, I talked about governments, what they're doing for the infrastructures. We have an example in smart grids and smart meters. Reporting, statistics, notification. Another topic is cooperation. So, we from the government perspective not always makes, let's say, regulations. Something is called soft regulation. The funny thing is, soft regulation is recommendations on a voluntary basis. So this means you have public-private partnerships, people sit together, they say, okay, for example, in the botnet discussion, we from the telco promised that we, let's say, look into the traffic, supervise the traffic. If we find some malicious, let's say, strange traffics, or if we see some denial of service attacks, we report it to the law enforcement people. That's something where you work together with the industry and the government and on a voluntary basis. So what one tries is to balance and to say, how can we improve this in a cooperation manner, and in which areas do we need a legislation? And from a government perspective, the message is everywhere where soft regulation doesn't work, the government comes with a real regulation. Okay, just to give you a couple of examples, that's not too boring. Disconnected devices. I mentioned it before. It's really amazing how many companies, small startup companies, go into this business. Who knows these chips from Arduino, this Italian company? Who knows the Raspberry chips? If you go to these sites, you know how many sensors you have there. Who plays with them? Ah, that's good. So this means this is something. There's one interesting part in it. Who has a car? Hands up. Not everybody has a car. You don't have a car. You don't have a car? You rent a car. You have a car at home? Ah! Okay, it's the wrong question. So, as I said, I have this professorship at the University in Munich, which is from the Joint Armed Forces. And 90% of the students are soldiers because before they become a lieutenant, or when they're lieutenant, they study there. They get paid by the army. Huh? So, the funny thing is the students have bigger cars than the professors because they're young and don't have a family. Huh? It's nice if you look at the parking place. It's completely different as in other universities. So, coming back to this, if you have a car, do you play with your car? Do you tune the car? Do you optimize the car? Who does it today? Nobody. It's also funny, because even if you're a student, if you have a car, you are too rich as a student today than I was 30 years or 40 years ago, because we didn't have the money. We had the 500 euros cars, and then we tried to repair it by ourselves. So the point is, do it yourself. And the interesting thing, if you look into this Raspberry, Arduino sensors, it's do it yourself by us. The technology is available for us. So what does it mean? Millions of people will make prototypes, and a couple of them will make products. If you just take a simple example, okay, we take the Arduino example because it's a nice example. You go there, you have a board, you can have a Bluetooth interface, you can have a sensor, you can also have a Bluetooth interface or an antenna. You put some couple of things together and you have communication, and then you put it in your home. You can lock the door, you can supervise the garden, the water, whatever. Does any of you, if you program there, put IT security into it? Does any one of you encrypt this communication over there? You do it?
Yeah.
Great. One out of? Okay. The others don't know what they don't do. So, what I want to say with this is, it starts in this, that you have this classical wireless LAN adapter, where the question is, okay, you might encrypt it, hopefully it's not a free one. The next one puts the sensors in it, and then you connect it to the internet. And latest when you connect it to the internet, the question is, do you think about that somebody can sabotage your home? Probably not, only a few people. So, if you look into this, there are examples of washing machines. There's an interesting thing today. Remember what I said 10 years ago, there were also the technologies there. What happens today is, and you know the company Bosch? Maybe. I talked with people from Bosch, and they said, okay, we now put interfaces in there. I said, okay, and what do you do? The answer was, we don't know. The problem is, the technology is faster than the business model, so what they do, they put the interface in, and then the question is, when does somebody pick it up and now connect your washing machine in your household? The challenge is sometimes, if you have a refrigerator, a washing machine, an oven, when do you buy everything at the same time? Only if it's in your house. If you buy one, the old one doesn't have the interface. So it needs some time until you can connect it. The other point is, there was, I think 1 year ago, somewhere in the blogs, an example, washing machine was hacked. Yeah? So, because it's just, let's say, an interface, which is not secure. The funny thing is here that 10 years ago, you already had the scenarios in the paper. If you read this paper from the BSI, the agency in Germany who did it, then there were examples. You go into a supermarket, and if you have your smartphone and you pass by the alcohol shelf, and if you like whiskey, it pops up and says, Scotch whiskey today is 30 euros instead of 35. So, the other examples are, you have a refrigerator, if you take out the last bottle, then automatically from the online store, somebody comes and sends you then a 6-pack of beer. So, these scenarios are scenarios, but they are not working today. But the question is, if this technology is implemented, somebody will pick it up. The message is, you can wait until Amazon does it, or you can be faster, build a startup and make a business model and can become a millionaire. Yeah? Okay, there are a lot of things in the press, what happens there. So, because it's a good thing, hopefully a couple of you also try to hack the system to show that there are vulnerabilities, because those people that the same message don't think about security. So, what we are starting, you looked into the smart, in this threat landscape report, now we make a report about smart cities, smart meters to look into it. Take, for example, television. There's a possibility to interact with the television today. So, and the question is, if you do this, how is information sent? So, the problem is that if you look from a business model, what typically happens is, Here is, let's say, Panasonic building televisions, putting the technology in. Then you have the broadcasting company who says, oh, this is great. Now we can do something where we interact with the people in front of the television, and you do something where the first time you can vote, or you can select something, or in the end you can also talk. Okay. So, but the television company is only interested in selling televisions, and the broad company is only interested in broadcasting. There must be someone in between who makes this connection to them, and these are third-party companies or products. So in between is someone who then deals with this data. So this means what happens in this ecosystem is, in Japan, the television is produced, in Greece it is used, the broadcasting is in the US, it's via satellite, and then somewhere in South America or South Africa or wherever is a company dealing with all this interaction. And then the challenge is that you have different jurisdictions. What is with data protection? As a consumer of this, at the end you don't know what happens, you don't know where your data flows. So the question behind is, how can you, from a security perspective and data protection perspective, from an end user perspective, be sure that all these things are work in a way which is in your interest from the privacy and security perspective. So, if you look into physical threats, there's something where you have a couple of categories today. You know, cybercrime, mentioned it, cyber espionage, you have cyber sabotage, you have cyber warfare. I think everyone knows about Stuxnet and the uranium plutonium plants. So what was this? Sabotage, warfare. It's a great area, but at least it was nation states acting against other nation states. So it shows that it works. So the question is now, if you are a terrorist, what do? You can poison the water of a big city. This is very difficult today, because if you have a big city, you can take Athens or Munich or New York, there are a lot of measures. The simplest measure, for example, for water is that when the water comes in before it goes into the, let's say, households, there are, let's say, like an aquarium where fishes are swimming. And then these fishes swim for some time, and like human beings, fishes get tired, then take out the fishes and put new fishes into it. So, and then you detect if these fishes are swimming. If they're not swimming anymore, you get an alarm. That's the easiest way how you detect if water is poisoned. Yeah? And there are hundreds of measures what people really take. This means water in big cities is one of the most secure systems because nobody wants that they are attacked. So the problem is now, if you look into other things, and you read sometimes here, what was this Polish airline which was hacked, yeah? If you read it in the news. The question is, if you have now a wireless LAN in a plane, if the wireless LAN is accidentally somehow connected to something where it should not be connected, and then you are sitting in the plane, row 28, and have remote control to the pilot, it's a bit dangerous. Yeah? So, and then the question is, how do you deal? Yes?
I think they didn't get hacked, they just went down because of DDoS. So.
Yes. The but, and I think this is something where the question is, when I give such a presentation, when is it a scenario, and then when is it just a tentative scenario, when was it done? Yeah? So, what you just mentioned, at least there's a proof of concept that you can attack it. Yeah? And the same is if you go into the towers are normal IT infrastructure. Yeah? So, and in all these things, the problem is that you have, until today, a very tailored approach where you say, this is responsibility for this time. If you're in a company, these people are responsible for the production, these people are responsible for the fences around the plant, and these people are responsible for the physical security. Because it was separated in the past. So, if you are now in a production plane, in a production plant, or if you are in a aircraft tower, or if you are in a power plant, what the people do is they open their internal systems to the internet. So if you think back, take a production plant, you have production control systems. You have special protocols. So it's proprietary software, and it runs in this plant. I mean, maybe in another manufacturer, another plant, it's even different software, but over the time you standardize it, but then you have it still in the plant. So what happened with Stuxnet? It was a simple USB stick with the malware distributed. So this means the first danger is now that the people come into the plant with this USB sticks. The next step is then that the people come with their maintenance PC and plug the maintenance PC into the production environment. And there are a lot of cases where malware on the, let's say, maintenance PC infected the system. So the next thing is then that the maintenance company says, oh, these people are too expensive, we do it remotely. Then you have a remote entrance from the maintenance company into this plant. So the first step is that you make a bilateral connection, then somebody says, we just use TCP/IP, we use the internet, and you connect it, and I can do it from Tokyo to Boston. And then it's over. And then the IT companies, or the IT people in the company run and say, we now need a firewall, we need virus detection, put all the stuff in. But over time you lose control. And now in a professional environment somebody says, you know the CP standard in this production environment, if you know it. You put here a wireless device, there a wireless device, you make wireless, then you have robots are communicating wireless. And then the mess begins. It's too complex, and if you now want to attack it from a, let's say, a sabotage perspective, it's the same as I checked in the past our PCs on our smartphones. What is the time? 20. Okay, so at this point the question is, what about security? And there are a couple of big challenges. I mentioned before these classical sectors like car, plane, trains. If you look at it, it was all on national level. If you remember the steam engines 120, 30 years ago, when the first steam engines blew up, the people made a regulation of standardization, auditing, certification for steam engines. And the same thinking is for the last 100 years in our manufacturing area. If you produce something, you have standards, you have procedures, you have ISO standards, everything, you make type approval, and in the end, you get a stamp. You don't have 100% security, but at least you know that there's a process. If you have a car, and if you take the wrong spare parts to your car, you lose a warranty. This means there are ideas behind that the supply chain is controlled. So, we can forget this in our sector, in the internet, in the IT sector. If you take the PC, you get it off the shelves, maybe you have virus detection on it, maybe not, then you put it on. If you have your smartphone, the smartphone is a cheap device, every 15 months you get a new one, so there's no business case. So this means what do you have there? ThinkPads. So, what is the business case for Lenovo to make it more secure? So, and if you put the things together, if you download somebody from the App Store, everyone can program something, yeah? Upload it and you get it. So, do you really know what the people do? Maybe you're lucky because they only steal your personal data, but if they put malware in it, what do you take? So, and then you ask, my PC doesn't work. Then you go to Lenovo. What does Lenovo say? You go to Semantic McAfee and say the virus detection did detect it. So if you have the terms of condition of a software, if you press it, it says it's used by your own responsibility, we have no liability. If you don't press yes, you don't get the software. So from a liability perspective, it's a complete upside down approach because the responsibility is in the user or in the company. So this means it's difficult because there's no real incentive. Some incentives, it's not incentive, it's a pressure where you say in certain areas you want to have a certification. Governments, for example, say we want to have common criteria certification for high secure hardware and software in the governmental area for the communication. You have a couple of areas in the industry where you also enforce common criteria certification as one way, but it's a limited area. Most of our software is just our hardware. So the question is now, how do we put in IT security by design? And this is a big discussion. The discussion is, I don't know, 10 years, 15 years, and it's still a challenge. And as long as we all click OK when we download something, nothing will change. But on the other, as end users, we don't have much possibilities. So, we need something where we, let's say, mail and smart home is only something which is coming up, where, say, the risks are much higher than in the past, that we come together, sit together, and this slide only describes it with other words. So, I want to give you a couple of examples. I think I take this example, yeah, this is a better one. If you have a car, today this car has this interface for maintenance in the garage. And this is a bidirectional interface. It's thought that you go with your car to the garage and the mechanical people can then look what is the failure. So, but it's also intended to inject test software or update. The but is that you now have applications with smartphones to this interface, which link it to web applications. This is nice. I, as a father, can sit at home in front of my screen and can see how my son is driving, because I can read all the information. But there were also some intelligent students who said, okay, let's test if we can inject something. So, it's in principle possible that you can harm this car. Another point is, you know, these sensors in tires for the air pressure in the tires. So, how do they communicate? From the sensor to the car. It's not secured, and you can manipulate it. So, the question is, does it harm much today? But if you're driving one of these, let's say, very expensive cars where you have the sensors in, and then you just manipulate it when it passes by, and it says, oh, zero pressure there, then you get an alarm on the screen and you stop. Okay, might not be fun, you lose time, it's not dangerous. But if you think about this assisted driving, then the question is, you know, this Google car, or the others, Audi, BMW, then the question, when will something happen? The problem is now that these scenarios are there, and there are, let's say, proven as a proof of, let's say, concept from a perspective of malware injection. So, experience, I think the only thing that I can say, experience shows that if something was there as a technology, this technology was misused, and at a certain point in time, this technology for criminals was also a business case, then criminals went to it. So, if you have sabotage or blackmailing or other types of things, why shouldn't it not come in this area? Why should this smart cities, smart environments, smart connection, whatever? So, this means if you look at it, we have a lot of things where we have smart cars, we also have buses, trams, railways. Look what you have today. You have for buses, police for a longer time, but even for buses in big cities, interconnection between the bus and the traffic lights. This means if the bus comes, the driver can press a button, then it goes to red for green, that the bus is faster, because the intention is that if the bus is faster than the normal car, people will use more public transport. So this would be fun if you sit in a cafe at a cross section and then just sit and say, oh no, I make every traffic light red, and now every traffic light green. What happens then? Nice question. Because the question is, when will it happen? The problem is you should not sit there nearby. Maybe you should then sit as long as was here with your PC and do it in a city somewhere, let's say in London, because then nobody can catch you. Okay, so This means we have to secure the systems. These are only some examples. This is a funny thing. This picture with this connectivity is about 10 years old. It's only drawn in different ways, but the idea is 10 years behind. What you have today is, if you have trucks, for trucks it works really perfect. You can sit on a truck, put your legs on the somewhere, and just follow the truck in front of you. If you are on highways, overtaking, assisted driving is really a safe feature today. Yeah? So even if somebody comes from the right, from the left, or does something strange, the systems are really mature for this if you're on highways. It's difficult if you leave the highway, if you have, let's say, roads in the countryside, because then it's more difficult to detect. I can also tell you here an interesting thing. Let's compare Germany with Greece. 10 seconds or minutes? Seconds. One thing what I learned here, I'm living here now for nearly 6 years, is when you drive on these roads, you have only these 4-lane roads here from, let's say, Chersonesos to the other end from Tuerac. Normally the streets are only 1 lane in each direction. So, what does it mean? If you're in France, you have a lot of streets in the countryside with their 3 lanes. So where you can overtake in the middle. Yeah? So the question is always which side takes the middle lane. Yeah? So, but here, what the people do is the following. You have on a street this white line on the right and this dotted white line in the middle. So, it's an unwritten rule. I think it's not in the regulation, yeah. Maybe it's also in Germany it would be forbidden. So what you do is you drive on this white line with the middle of the car, yeah? So this has 2 advantages. You have long time to go to Hanya, or if you go to the south. So if you get tired, you just only have to follow this white line. It's a nice advantage. And it keeps space in the middle. You can overtake. So in the beginning, it takes a couple of months to learn it. And now when I'm driving, I think, oh, this stupid tourist. Why do these tourists drive on this? This should drive on the right side. Because tourists don't know it, yeah? So only the tourists are blocking the streets. So, when I come to Germany, and this is a personal experience, I start driving, my son is around 27, then my son says, oh Papa, you're driving crazy. Why? You're driving on the right side. Ah, okay, then we have to adjust. It's really amazing how you adjust to this. But, if you have this nice Mercedes, what does this Mercedes do? It detects this white line. If you're driving on a German street and you just pass it, it makes beep. You have also cars who have then a motor in the steering wheel. If you pass it, they really force it back. Now this car comes to Greece. So this is something where it's okay, this is what I told here. So, what is the conclusion? What we try to do is to analyze what I told here, write papers about this, advise the politicians, talk to the industry, look for a practical approach, look as far as possible in the future to anticipate the things, talk to the stakeholders to have these public-private partnerships. What is important is we have a technology evolution, and just when you mentioned this Arduino, if you look on the website, I think there will be every week new sensors, new things. So it really is rapidly increasing. So we'll see these things in the field, also in a professional way. The question is then, how can you balance between economic growth, creating jobs, implementing new technologies, and putting in security? And what is a challenge for us in Europe is that we have the same regulation implemented in the member states. This means it's difficult for companies if the legislation is different because they have plants in different areas, so they don't want to have different legislation. So this means in the end what we try to do is raise awareness, dig into the technology, make scenarios for the future, give advice, and by this, step by step, increase the security. Thanks for listening.
So thank you very much for this interesting talk and for finishing true to schedule, so we have time for discussions. I would like you to answer the questions from the microphone there. So we have questions.
You mentioned that the Internet of Things is still evolving, so sometimes there's always new products. How the governments can regulate something they still don't know?
Okay. The question is what we want to achieve, yeah? So, what one must avoid is that you put explicitly technologies into the regulation. What you can do, for example, is a good example is cloud computing. So, what we started is in cloud computing to discuss with the industry standards and certification that cloud computing providers are certified. And what you see now is, on the side, there's a big list of certified companies. So, this is the soft approach, and if this works, over time, the market should then solve it, that people say, I only go to these services which are certified and approved. It's the same thing in the other cases. If you want to buy a product, you go on a website, meet the tests, and then you buy the best product. So, the step is then for the government, do we need legislation? And then the legislation would say, okay, you must have a certification. You must have an audit. So you wouldn't put in the regulation, is it this or that? You would say, if you have a smart meter, if you want to implement it, you have to have a certified smart meter, that's regulation. And then you have other bodies who sit together with the industry, the standardization bodies who say then, take the example if you have the mobile phones and the base station encryption to your smartphone. The protocol is standardized, yeah? So you know what encryption protocol, what key lengths you have. But the regulation would only say it has to be encrypted.
So isn't it sometimes frustrating to you that you only can give advice, do recommendations, talk to people? Do you wish to have some means to really push things forward, to force people to do things?
It can be frustrating, but one can explain it. I think you have to look at in the history of the last 100 years, when our engineering evolution was fast, but it was step by step. Our evolution in this sector is 10-15 years. You remember what I said, no mobile phone 20 years ago. So the challenge is we cannot cope with this rapid change currently because the industry is faster than, let's say, what we want to have. So on the other hand, you see it, what happens. In Germany, you have the Federal Office for Information Security. They changed their law in 2009 and put in the regulation of the BSI giving warnings. Just now, they passed in Germany 2 weeks ago the IT security law, where they give more power to the BSI. So this means what you see that happens in Germany is what happened in other sectors like cars or trains, that you give an agency more power to intervene. What we do on the European level is that we have the so-called ENISA directive. The ENISA directive is an approach to say, and then you see where we are. We want to have better information exchange between the governments. In a case of crisis, you want to have crisis management. If you know Estonia 2007, this attack on the government. So we want to have, let's say, certain first steps. We have telecommunication, I mentioned the breach notification. So this means it's picked up and legislation is behind it. So the question is now, if you're in the healthcare sector, if you talk about Ebola, you have experience for a long time, and you have this agency, and a health agency can go into the pizzeria and close it if it doesn't have the hygiene. Yeah? So the question is, why is it done? It's always done when something happens. Steam engine blow up, reaction. Plane crashes, action. Fukushima was really a disaster, you have some action. So the question is, it looks like something has to happen in the IT sector that you come to more, let's say, influence. And this is a challenge.
You mentioned in the beginning that basically governments are responsible for the security of their people. Yeah? And what we get from your presentation is that government is not doing its job. Right? If we look at developments in day-to-day life for consumers, like awareness of ecological questions, bioproducts, right? So we one way to heighten the awareness was to come up with well-defined rules for producing such products and labeling them with quality certificates. Right? We see that with security in some places on the web today as well. Do you see chances for a strategy or an approach like that with secure IT products, where you get labels and people buying, installing products, software, can at least find a little bit of information for them to pick products and agree to understand them? Maybe that is also an incentive for software houses, for building products that achieve that level of security. Is that just a fancy idea, or is it going that way?
3 answers to this. Completely agreed. I don't see it in the next 10 years. And I don't know what comes then, so I don't. So the answer is no for the next 10 years. The second is, the reason is, everything what was done in the past was done on national level and then harmonized between the states or across the Atlantic. Because you could make the decision on the territory. With the internet, you don't have this chance today. Because the problem is that the cultural system in China, in Europe, in the US, if you talk to the OECD, to the ITU, it's all different influence and interests. And if you look what happens today, look what's currently happens is negotiation for the nuclear power plants with Iran. Yeah? You see how difficult negotiations is. If you look into the ITU is a bit a battle between Europe losing influence and countries on the other side who are developing countries get more influence. So it's also a fight about influence in the cultural system. So the problem is what we want to do is a very long process on the international level. And the third is my own theory. In the Middle Ages, we were governed by the churches. Until a couple of years ago, we were governed by nation states. And today, we are governed by 5 to 10 big companies. The Amazons, the Googles, the Facebooks, the Alibabas, the Tencents, you can count them so. And the problem is, if you look today, if Samsung or Apple make a mobile phone, they make the standard. If Apple implements the payment in the model, or as now this music streaming thing, if this is accepted by us, this becomes the standard. And what you see in Europe, the discussion about Google, Facebook, right to be forgotten, our data protection rules, is a fight about principles. So this means when the power goes to the companies, to the global companies, the government has limited power. And this is where I see the evolution.
Okay, I think that was a good concluding statement.
Okay.
Thank you again. We will have a break now until 11.
Thanks a lot for listening, and thanks also those that you really reduced looking into your computers. Thank you. I appreciate it. Ja.
Vorschläge waren,